This is topic 19-2, simplifying radical expressions. Our essential question today is how can I simplify radicals that has both variables and numbers? Our bell work today is a review of linear equations. It's asking what is the x-intercept of 2x minus 3y equals 18? Your hint is to solve for y equals and then use your calculator. So in solving for y equals, we want to get the y by itself. So we're going to draw a line down the equal sign and box in the y with its coefficient. What we want to end up with is y equals something times x plus something. This is slope-intercept form. So our 18 is already on the same side as the line. So it's a free faller. It just falls down to the blank that didn't have the variable x with it because 18 doesn't have x with it. The 2x, we move it to the other side. In a sense, we're subtracting 2x from both sides. So when I move it across the line, I change the sign. That tells me the number in front of the x is a -2. And then last but not least, the number that is with the y, it's a -3. This is -3 times y, so that means I need to divide everything by -3. This gets my y by itself, and so when I simplify it, the -2 over -3 simplifies to a positive 2/3 times x, and then plus 18 divided by 3, that actually is a -6 or -6 here. So now I have this equation in slope-intercept form, which means I can use my calculator. Notice this is asking for the x-intercept, not the y-intercept. So I need to make sure that I am finding the x-intercept. So I'm going to put this in my calculator. I have the 2/3 x minus 6 in the calculator, and then I can look at the graph and see, hey, in this graph, I'm looking for this point right here where it crosses the x-axis. So sometimes the graph is easy enough that I can read it. I think it's crossing at the 9, but just to be sure, I'm going to check my table. So to go to the table, we are looking for, okay, so to get to the table, that is second graph. And I'm looking in the table where the y-coordinate is 0. And when the y-coordinate is 0, when our x value is 9. And so our x-intercept is 9, 0. So I was correct when I looked at my picture. Okay, here are the answers to your assignment from last night. If you need to, you can pause the recording in order to check your answers. If you want to check your answers on your own, use the calculator for 1 through 9. Actually type this in exactly how it looks. These are perfect squares. Your calculator will be able to give you the answers. To see the work shown for 10 through 18, you will need to pause the video in order to see how I came up with the answers for 10 through 18. So now let's look at our topic for today. And today we have not only numbers but also variables. And so we're going to start by simplifying radicals with just the variables underneath. The first one is a squared. So what we're going to do is stamp out the a's. They're a squared, that means there are 2 of them. And just like we did yesterday, if there are 2 of them in my house, I tell them to get out. So when I tell it to get out, it shrinks back down to 1. Notice there are no more variables underneath once I told those 2 to get out, so my answer is just A. 2, we have a cubed, so again, we're going to, there's 3 of them, 1, 2, 3. Okay, it's doubled in size, or I got two of them, or they doubled, so I need to tell them get out. When I tell it to get out, it comes back 1. I still have an A left underneath, so it becomes the square root of A. So this one is A times the square root of A. Next we have 4 of them, A to the 4th. That means there are just 4 A's. 1, 2, 3, 4. I see a double, get out. Another double, get out. So that means there are 2 of them out there. So first double, there's the first one. Second double. No more A's underneath my radicals, so my radical's gone. Well, A times A is just A squared. Looking at number 4, we have A to the 5th. So again, I'm going to stamp out A 5 times. 1, 2, 3, 4, 5. I'm looking for doubles, so here's a double. They're getting out. Here's my second double, getting out. And what I'm left with is still 1a underneath the radical. So I get a times a, this is a squared, and then an a left underneath the radical. A to the 6, there should be 6 a's, 1, 2, 3, 4, 5, 6. Looking for my doubles, here's a double, tell it to get out. Here's another double, get out of that radical. And then my last set of doubles, getting out of that radical. There are no more a's left underneath, so this is a times a times a, or a cubed. Some of you may have seen a pattern by now, but in case you haven't, we're going to continue on. We have a to the 7th power, that's the square root of a to the 7th. So again, draw my radical. There's 1, 2, 3, 4, 5, 6, 7. Get my doubles. Here's a double. Get out. Another double. Get out. Another double. Get out. And now I am left with still 1a under the radical. I have 3 a's out front, so this is a cubed, and then I still have a square root of a in the radical. So my question now is, what's the difference with the variables having an even exponent versus an odd exponent? Have you recognized the pattern? Because what we're going to see is that, right now I'm dealing with numbers that are less than 10. But if I get a to the 24th power, I don't necessarily want to stamp out 24 a's. I can definitely do that, but is there a shortcut or a pattern? So let's look at our even exponents. When it was a squared, we end up with just a. A to the 4th, we ended up with a squared. When it was a to the 6th, we ended up with a cubed. So the pattern is, if it is even, if we take that exponent and divide by 2, that tells us how many of the variables we are taking out of the radical. So if we divide the exponent by 2, this gives us the number of variables out of the radical. Okay, the number of variables that we can take out of the radical. So let's look. A squared is 2 divided by 2, that gives us 1a. A to the 4th, 4 divided by 2, that gives us 2 a's that are taken out. A to the 6th, 6 divided by 2, I get a to the 3rd power. Now if it's an odd exponent, let's look at that one. We have a cubed, I end up with a and then a square root of a. A to the 5th, we have a squared and then a square root of a. A to the 7th, we have a cubed and a square root of a. So something that you should notice is that if it's an odd exponent, you will always have a square root of a, or square root, still remaining inside. A square root with the variable still remaining inside. The ones that we take out is, hey, I can kind of do the same thing I did with my even exponents. And I'm going to show that with my number 7, or number 6, sorry. I have a to the 7th. If I do 7 divided by 2, because I said divide by 2, we'll end up with 3, and it has a remainder of 1. So this 3 is my exponent. The remainder of 1 is the one that's left underneath the radical. So we're going to say with an odd exponent, you're going to have 1 remains inside. And then we're going to do the same thing we did before. We're going to divide that exponent by 2 to say by 2 to take out of the radical. Another way that I like to think about this, and I'll show it on some more, is the a to the 7th. I could actually rewrite as a to the 6th power times a to the 1. So here's that 1 that remains. And now I'm dealing with an even number, and if I do 6 divided by 2, that gives me the 3. That's the exponent I started off with, and then this a to the 1 stays underneath the radical. So I'm going to do it both ways, and then you can decide which way works for you. Whichever one is not confusing, that's the ones you want to choose. So let's work on some problems. Number 7, we have a to the 24th. Let's recognize it's even. So because it's even, we're going to do 24 divided by 2. And 24 divided by 2 is 12. So that means my answer should be a to the 12th power. Again, I could stamp out 24 A's. If you want to do that, 1, 2, 3, 4 on to 24 and bring out all your doubles, you're still going to come out with a to the 12th power. Number 8, we have a to the 120th. Again, it's even. So I'm going to do 120 divided by 2, and that comes out to be 60. So my answer then is a to the 60th power. To the 60th power. Number 9, this is a to the 31st power, the square root of it. This is an odd one. So one way I can do is say a to the 30th and then put an a to the 1. Because again, if I put them together, that's going to be 31. So now I can do 30 divided by 2 gives me 15. So this comes out to be a to the 15. That's outside. I still have an a to the 1 power underneath. Or if I keep it as a to the 31, then if I do 31 divided by 2, I get 15 with a remainder of 1. So again, the 15 tells me a to the 15th, and the remainder of 1 tells me that's 1 underneath. You should always get a remainder of 1. So here's how your calculator can help you out. When I use my calculator trying to figure out, if it's even or odd, I can still type in the odd number, 31 divided by 2, and I will see 15.5. The number in front, the 15 before the decimal, is going to tell you what the number is that you raise it to the power of outside of the radical. I'm going to ignore the 0.5 because the 0.5 represents the one that is still underneath there. Okay, it's just saying what's 1 divided by 2, that's 0.5. So if I do number 10 that way, again, 101 divided by 2, I'm going to get 50.5. So this tells me I'm going to have a to the 50th power, and then that 0.5 tells me there's 1 left over. Again, that is saying that I'm doing 101 divided by 2. That gets me 50, and I have a remainder of 1. And I'm using the calculator to come up with that number right out front only. It's only giving me that number up front, the 50. Okay, or you can rewrite it as a to the 100, and then here's my a, that's the one that's always remaining. So 100 divided by 2 is 50, and then I still have an a underneath. Again, choose your method. Right, now we have both variables and numbers, and so we're going to, in a sense, do two problems. I want to work with the numbers, and I also want to work with the variables. So I'm going to split it up, and let's do the numbers. I want the square root of 81, and when we did these yesterday, our first thing was to do it on the calculator and see if it is a perfect square. So square root of 81, and sure enough, we get it's equal to 9. So we've taken care of the square root of 81. Now I want to take the square root of a to the 4th, b to the 6th, and c to the 10th. So first let's tackle a to the 4th. Well, that'll be 4 divided by 2 gives us 2, so that'll be a squared. B to the 6th, that'll be 6 divided by 2 gives us 3, so that's b cubed. C to the 10th, that's 10 divided by 2 gives us 5, so that's c to the 5th. So I've separated them, now I'm going to bring them back together. This will be 9 times a squared, b cubed, c to the 5th. So I broke it up, again, did the number first, then I dealt with the variables. Next one, we're going to do the same thing. Breaking it up, I got the square root of 75. want to do the square root of 75. If I know my perfect squares, I know 75 is not a perfect square. If I don't, I'm using the calculator. I get an ugly decimal. I'm going to see if can I change that to a fraction. It's an ugly fraction, so that tells me I do need to factor. And so when I factor, I see 75. I know it's divisible by 5. So I know 5 times 15 will give me 75. 5 is prime, 15. I know that that's 5 times 3. So again, doing what we did yesterday, I'm going to rewrite my radical with 3 times 5 times 5. I see my double. I can take out the 5. It's the square root of 3. 5 square root of 3. So we've taken care of the variable. Let's look at, we've taken care of the number. Let's look at the variable. I have x squared and y cubed. So x squared is even. I get 2 divided by 2, that equals 1. So that means I have x to the 1 power. Y cubed is 3 divided by 2. That gives me a, well, let's see what happens. If I use my calculator, 3 divided by 2, that gives me a 1.5. So I know I got a 1, and then I have a remainder of 1 because I always have a remainder of 1. So I'm going to do y to the 1 power. Remainder of 1 means I still have a y underneath. So now that I've dealt with them separately, I'm going to put them back together. What I mean by that, the numbers that are in front of the radical go in front. So that's a 5, an x to the 1 power, and a y to the 1 power. What's underneath the radicals go together. I have a 3 and I have a y. If I could multiply anything together, I would, but in this case I cannot, so I'm done. This is 5xy, the square root of 3y. 15, we're getting a little bit more complicated. We already have numbers out front. So that's going to tell me that I'm going to have some numbers out front, negative 5xy. But now I need to break down my number, the square root of 72. When I do the square root of 72, again, if I don't know my perfect squares, I'm using the calculator. I get the square root of 72, press enter. It's a decimal, so it tells me we need to factor. 72 is 6 times, nope, I'm sorry, it's 8 times 9. Okay, and then 8 I know is 2 times 2 times 2. So I'm going to go ahead and write that out. 2 times 2 times 2. And then 9 is 3 times 3. I got a double, it's a 2, comes out. I got a double, it's a 3, it comes out. I'm still left with a 2. And then 3 times 2 is 6. I still have a square root of 2. Let's look at my variables. We have the square root of x to the 5th and y to the 4th. X to the 5th, this will be 5 divided by 2. That'll give us 2 with a remainder of 1. So this will be x squared. And then there's a 1x underneath the radical. The y to the 4th, that's 4 divided by 2. That gives us 2. So this is y squared. So now that I have them separated, let's put them back together. So I'm putting them back together. I start off with the negative 5xy, which is what was out front anyway. Then I have a 6. And then from my variables, we have an x squared and a y squared. Underneath the radical, I have a 2. And I also have an x. So now when I simplify further, I can multiply my numbers together. So negative 5 times the 6, that's negative 30. Then I have x times x squared. Okay, so x times x squared, that's a total of 3 x's, so this becomes x cubed. Then we have y times y squared, so that's a y times 2 more y's. That gives me a total of 3 y's, so that's y cubed. Under the radical, we have 2 times x, so 2x. So this time we had a number out front. We simplified the number under the radical, then we simplified the variables under the radical, brought them back together. Let's try one more. This time we have numbers and variables out front again. So I know at the very end, we're going to start off with 3mn squared. So now we're going to break down the number and also the variable. So let's break down the number. We have the square root of 121. Again, using the calculator because it's the first thing we're going to try. Take the square root, 121, and it equals 11. That is a perfect square. Now we're going to break down our variables. It's the square root, m to the 4th, n to the 5th, p to the 7th. So m to the 4th, I'll take the 4th divided by 2. That comes up m squared. N to the 5th, it's odd. That means I'm going to have a remainder left over. So n to the 5th, 5 divided by 2 is 4 with the remainder left over. P to the 7th, it's odd. That means I'll have a p left over. And then 7 divided by 2 is 3. With 1 left over, I have my 1 left over still in the radical. So now I'm putting it all together. I have 3mn squared times the 11 that I got from my number. There's nothing under the radical for that one, so times the m squared, n to the 4th, p cubed, and under the radical we still have n and p. So putting it all together, 3 times 11, that's 33. M times m squared, that gives me a total of 3m, so m cubed. N squared, that's 2 of them, n to the 4th, that's 4 of them, so that's a total of 6. That'll be n to the 6th. And then last but not least, we still have a p cubed. And then I have what's under the radical, n and p. So our answer is this long thing, 33, m cubed, n to the 6th, p cubed, and then under the radical, n and p. So to answer our question of how can I simplify both variables and numbers, first thing we did was get my pen to work. First thing we did, we used the calculator to simplify the number. If it's possible. So to simplify the number under the radical. If not possible, then we factored and simplified. Then we simplified the variables. If it's even exponent, we divide by 2. And that's to get the variable out of the radical. If it's an odd one, this is the same as even, but have 1 left over. Or I should say 1 remaining in the radical. And then last but not least, we put it back together. So when you do your homework or do the classwork today, it has several different things. Remember that your answer choices, you do have scrambled answers at the bottom, so make sure that you are checking your answers to make sure that you have them correct. Okay. All right, you do see there are some review problems at the very end, 19 and 20. 20 should look exactly like our bell work. 19 is a little more. Oops, didn't mean to show that last one. All right, this concludes topic 19-2.